My name is Daniel Nenny, and I'm the founder of SemiWiki, the open forum for semiconductor professionals. Since going online in 2011, SemiWiki.com has registered more than 200,000 members. If you're not a member of the SemiWiki community, please register as my guest. I hope to see you there. Today's webinar is titled The ROI of User Experience Design, Increase Sales and Minimize Costs. The speaker today is Matt Genovese. Matt founded Planorama Design, a user experience design professional services company, to design complex technical software and systems that are simple and intuitive to use while reducing internal development and support costs. Staffed with seasoned engineers and UX designers, the company is headquartered in Austin, Texas. Please use the chat box for questions and we will answer them during the Q&A. Okay, let's get started. Over to you, Matt.
Thanks, Dan. I appreciate it. So as we talked about, the title is the ROI of User Experience Design, and we'll jump into it. So the agenda for today is really rather simple. We're going to talk about the state of semiconductors and IoT today, what is user experience design, and then talk about how it works and how it can really affect your business. As for me, I have a career spanning about 25 years. I'm the founder of Planorama, and I started my career in chip design, and I moved into software and software development, test strategy, user experience design, and I've been running the company now for about the past 5 years. I'm going to talk a little bit about where we started. So I started back in 1997 at Motorola, and we sold chips, we sold eval boards, and we even sold a few phones. Even back then, software was a bit of an afterthought sometimes, and I'll admit it. When I had the StarTAC phone, that software was difficult to use. Those phones were not necessarily easy to use. The emphasis was on the hardware. It was still a nascent and growing space, and the real focus, the real emphasis was on technical superiority. So software became a little bit of an afterthought. However, though, things have changed. First, semiconductor companies are now largely vertically integrated, meaning that they have entire solutions that are sold by the same companies that were selling chips before. These solutions, these integrated solutions like I'm showing here on the screen, often include software. And so therefore, semiconductor companies are having to become software companies. And secondly, for the same reason that companies sold eval boards, which was, again, to get their customers started, get them going so they can move faster. They now are now selling software, or now bundling, I should say, software with their solutions so that their customers can ramp up more quickly. So think of it, instead of eval boards, it's software that will get their customers developed and get them to production and ramped, because then, of course, is generating revenue for their customers and generating revenue for the semiconductor company. So lots of different devices. You can see here different edge devices, cameras, devices that are made specifically for doctors and healthcare, and all of these have software. And it's not just software that's on the device; it could be software that is running from a web application. And in fact, here is a screenshot of NVIDIA. NVIDIA has a fleet command application. It's a great example, really good example. I'll tell you, it's hard to find semiconductor companies sometimes that show off their software. It's hard to find it on the web, and as it turns out, NVIDIA does a great job of their UX design. They're I think one of the companies to look out for how well they design their software, and it shows. I'm not an end customer of theirs, so I'm not getting paid by NVIDIA, but I'd certainly want to use this software. It's very user friendly. So we'll talk a little bit now about what user experience design is. Every component has an interface, and so I'm going to just show a little, example. And this is the PowerPC 603E. It's a screenshot I grabbed, but it was a processor I worked on when I was at Motorola. But these have interfaces, right? This interfaces to a board, right? And that board interfaces to an enclosure that has other components in it, right? And eventually you get to the point where there's software, and that software is going to be what controls your product, your that application is where your customers are going to achieve value from your product. I mean, granted, the product has a lot of technology inside of it, a lot of development, a lot of hours have went into building that. But many times the software is where they experience that value. And so what happens? Well, if that software is so important to experiencing the value, then we ought to put thought into how that software is designed so that your customers, that interface between your customers users, and your product, we should put in as much thought into that as we do with every other interface that goes all the way down to the chips, right? So that's what user experience design is designing the interface between humans or your customers and the software that really, again, exposes the value of your entire product. So a lot of you probably remember the term user-friendly that came out, in the 80s, back when computers were called micros at the time. And people were just starting to wrap their heads around having a computer themselves. And user-friendly was a term that meant, well, how do we make this something that's usable, that people can actually sit down and use and not have to use wires or flip switches. So UX design is really the discipline that makes products user-friendly. So what does that mean? Well, it tends to be focused on user-centric design, meaning that we care about solving problems for the user, right? And UX designers are normally the advocate for the user, right? They're the ones thinking about how the user is going to use the product. If you don't have UX design, what tends to happen is you don't have necessarily an advocate for your users, for your customers, and therefore your products can tend to be dev-centric. Whatever is easiest for developers to design, to create. UX design involves adapting to your users, right? Software should mold to your users' needs. It shouldn't be the other way around. And for a long time it was. You had to go and figure out how to use a particular piece of software. UX design flips the table on that and says, no, the software should be adapting to how your users think and their existing workflows and modalities. UX design is focused on established design patterns. It's an entire area of research. And by the way, one in which our UX designers are all trained and they have that background. It's an area that has roots in human factors, ergonomics, psychology, even how we think about groups of items, right? For example, when we use our eyes, where do they tend to drift to? All of that comes together in established patterns, and it's not, it's a discipline that again many folks, especially in the semiconductor side, don't know about, but it's established. It's an established practice, especially in pure software products. You'll find UX design as an intricate part of the entire development process. So what's the payoff? Well, products just work. If you've ever had to pick up an application, whether on your phone or on your laptop, and you can't figure out how to use it, like it doesn't make sense, nothing's where you think it would be, that means it probably wasn't designed, or it wasn't designed well. And you want to prevent the user from thinking a lot. In fact, there's a great book called Don't Make Me Think. And that's exactly what you're trying to do. If the software becomes transparent and the user can just pick it up and know what to do with it, like a hammer or a screwdriver, then it's done right. What else? Well, with that, you're going to allow your customers, your users, to onboard more quickly, right? They're going to be able to achieve value faster when they get onto your product and they, again, using your software to experience the value of your product. You can also avoid costly redos and this is an important one, if products are designed for the future, meaning that you know that something's coming up down the road, but you're not going to build it right now, you don't have to redesign it later. The designers can accommodate for that. And it's very important. You can avoid a whole bunch of redos. And in fact, they're also going to help your customers not have to learn a whole new interface just because you have to do a redesign because there was no forethought into features in the future. It also helps, by the way, to know that if you're designing for certain types of devices, you have to design in appropriate ways. You can't take the same application that is on a laptop and put it onto a tablet or a phone. It doesn't work the same way. And finally, when it comes to bugs, when you have a well thought out user interface, it turns out the developers have a much clearer path, and QA has a solid spec to check against. So those killer production bugs don't tend to make it out the door. And that's, of course, a big payoff as well. So I'll say UX is, it has a lot of value in the process, in the software development process, and especially when it comes to IoT. Let's talk about what that is. I'll say that you could break it into 3 categories. It affects your sales and retention, it affects your time to market, and it can reduce your costs. So in terms of sales and retention, I'll say that product differentiation is something that most products want to achieve, right? They want to be able to differentiate themselves from their competitors. In the end, it's people who are not companies who are making the decisions to buy the software product or your IoT solution. And so people will have to use it. Then they have a say. And so you can distinguish yourself and distinguish your product through a well-crafted user experience, basically a well-crafted customer experience for your product. And again, if software is the place where they're achieving a lot of the value, or they have to use that software day to day to achieve certain value, it's important to put effort into that, and it will differentiate you in the market. Ease of use, and I can't mention this enough about being user friendly. There are products that I'm sure you have, and I have too, that they do most of what I need. Maybe they don't do everything, but they do most of it. And I don't want to give them up because they're so easy to use, right? There are times where technology and features don't always win the day, right? It's not just that. If it was, then people, when they're buying cars, would not think about the interior, the dash, the cup holders, the headroom, right? All of that matters when buying a car. And it has nothing to do with the technology necessarily, right? It's the ergonomics of it. It's how easy is it, how comfortable is this to use, to be able to do what I have to be able to do. Those things matter. When we get into time to market, designers typically design faster than developers. That's what they do all day long. And it turns out developers typically develop faster than designers. So if you make developers or product managers or anyone else design the application, it slows down the entire process. So it turns out if you bring them in and you have everybody doing their job, if you have the developers doing their job, developing, you have designers designing how the screens and the workflows are going to look, then everybody has what they need to execute. And in fact, QA is the same issue. If you have solid requirements, including the visual requirements, the user experience designs, the UI designs, that means QA has something solid that they can work against. They know how it's supposed to work, the interface, and they can check against it. And most bugs can be caught early. Okay, and again, all 3 of these items are going to affect your time to market. And finally, about reducing costs. Well, if you get UX involved early, they can consider how software has to react, especially based on hardware. If you're talking about hardware products or IoT products, typically you're going to have to concern yourself with the asynchronous interactions of hardware. Things that can happen with hardware, or robotics, right? There's all kinds of things that can happen with physical movement for hardware products. right? The encoders may be off, sensors may be giving you errant information, sensors may be giving you correct information, and you have to deal with it in a certain way. All these different types of synchronous and asynchronous events, the software needs to deal with that at some point. And designing the software purposefully in a way to manage that is a non-trivial task. It's not something that should be an afterthought. And so therefore, UX design needs a spot at the table, a seat at the table to be able to understand how the software is going to work. Because again, the requirements that they're producing are going to be necessary downstream to developers and QA to be able to build the product. So as part of that, developers tend to, and QA as well, tend to execute more efficiently because they have the requirements in hand. And I'll also say that customer support and training tends to be reduced. You don't need as much of that if you have well-designed products. So I'll go through some quick examples here. This is a remote application deployment manager that we designed. It was for a SaaS or a complete edge solution. So it has deployment, monitoring, upgrade, and version control of applications for software running on edge devices. It's a perfect example of customer enablement software, right? You want to ensure that your clients' customers can build and deploy their own solutions quickly. And this kind of software enables that. And so for us, with a seat at the table early on, right, we could know how edge devices work, the error modes, what types of things can happen, and design that into the software purposefully, right? It's not an afterthought. It's not an, oh boy, what happens if this is the case? We got to design that in now and I got to handle all these scenarios. No, we think through that early on. And then by the time that we're delivering our requirements, right, with high fidelity designs, with the requirements documentation that we deliver, which turns out to be things like user stories, test case documentation that we at Planorama deliver, the developers could build it quickly, right? We made them more efficient, right? And that's, again, reducing costs and getting that product out to market more quickly. At least in the whole process, in the scheme of things, we don't want software to be the long pole in the tent. Here's another example. This is some of our work in what we call digital transformation, taking an installed product and turning it into a SaaS software as a service implementation. It's also a great example of how, having a mutual background in semiconductors and EDA, as well as modern SaaS architecture, pays off, and it paid off for us at Planorama and for our client because we have that background. For this client, we could map out the interface to support cloud jobs, mobile usage, figuring out what features do designers need on a phone if they're going to be away and want to check the status of their jobs. We can design that into other applications for different devices like mobile or tablets. And then we also talk through the type of architecture for the application itself for the SaaS, whether it's tenanted, multi-tenanted, if it's going to be in the cloud, if it's going to be on secured, on-premise installations. All of those architectural decisions make a difference when it comes to designing the application. So it turns out many of the conversations that UX has in the beginning are with the software team as well as customers, and that helps to solidify how the application needs to work and what it needs to support, that software application as well as the devices connected to it. The more of those conversations we can have early on, the more surprises we can avoid later. So, as I think we're getting close to wrapping up here with the slides, I put this as a takeaway, and you'll see it here. It's about 10 ways that you can self-evaluate the usability of your software, right? And I didn't want to make this an eye chart, but if you reach out to me, I'll be happy to send you a PDF that will allow you to review your systems yourself. But there's a number of these that you could see right away will make a difference, right? Like visibility of status, of system status, and error prevention, right? Those are very necessary in hardware, software integrated systems where you can have problems pop up asynchronously, right? You can't always rely on the software doing something and the hardware responding. Sometimes the hardware is going to respond out of nowhere and it's going to give you correct information or incorrect information. How do you deal with that, right? The user control, the third one down on the left, validating the user's workflows. Building paths for them in the application is very important. We call them workflows, and we try to adapt them to how the user already thinks of, or how they already work today, or how they think about the problem they're trying to solve. But then also building in some manual control when required for the situations that we necessarily can't predict. Error prevention. Again, as much as we can, we want the software to manage the errors under the hood so that the user can just manage by exception as much as possible when the time comes. And then finally, over there on the far right, the help and documentation. If you do everything right, your software won't be hard to use, and they'll be able to just pick it up and go. But there are times where you need to provide that assistance, and so again, building that in purposefully into the application, that is very important. And so again, if you reach out to me, I'll be happy to send over a self-evaluation PDF that you can look at your own software and evaluate how it measures up to these common heuristics. And finally, again, please feel free to reach out. My email, actually, you can reach me on planorama.design/podcast. I'd be happy to, for anybody that wants it. And again, this is not a sales pitch. I have an engineering background. I'm not born a salesman by any stretch, but I'll be happy to have a call and talk through any of the challenges that you're having, and I'll give you my best advice. I've seen a lot. I'm sure you have too. And I'd be happy to chat and see, how I can help. And I'll just make that offer. So with that said, I think I'm wrapped up.
Thank you, Matt. Great presentation.
Thank you.
It's time for the Q&A. Let's get started. We do have a question. If you have questions, just put them in the chat box and we'll answer them as accordingly. So first question, Matt. My company is building a customer-facing SaaS to manage our IoT products. What advice would you give?
Oh, well, thanks. That's a good one, and I've be honest, that's one I've heard before. Yeah, SaaS applications are not necessarily what most semiconductor companies, depending on your company, if it's one in that space, they're not necessarily well versed in SaaS. So I would say, from my experience, first consider whether the SaaS needs to support on-premise or not, or if it's going to be in the cloud. Many semiconductor companies are very careful with their IP, and rightly so, right? When I was at Motorola, that was all heavily guarded, and so therefore, if you're going to be building a SaaS, most likely it may have some on-premise support, or it may have some cloud support, or both, and that will make a difference. How security is managed and how data access is controlled, both physically and then through permissioning in the application. Let's see. Second, I would say consider SaaS administration early in the process. Many companies, they haven't built a SaaS before. They're going to put off considering things like all the users and the roles and the permissioning, how to get users into the system, tenant administration, data access, things like that. And if you don't think about those early, they can bite you later. And I've seen that firsthand. So if you want to avoid, I'll say, costly redos, in both the architecture and in the UX, those decisions, by the way, those administration decisions affect both. They affect how the application is actually implemented, the coding, as well as how it's designed, how the user is going to manage all of that. You want to have, again, UX at the table, and we should be discussing this early, not later. And I guess that's probably the third point I'll make is that if you can get UX design involved early, you're going to be much better off because depending on the hardware, um, the software's user interface will need to support special circumstances most likely. And that software should be designed intentionally to support that. And as I mentioned before, mentioned earlier in the conversation here, UX needs a seat at the table. Software needs to be designed with the same care that hardware is designed, and so that would be what I would say.
That's a good answer, man.
Thank you.
Another question: you mentioned having UX design involved early. Can you reduce internal costs? I mean, how does that work?
Sure. Yeah, it's not an obvious thing. People, when they hear about UX design, they think, oh, it's pretty pictures. It's how do you make the application look aesthetically pleasing? And they don't think about it in terms of usability, and they certainly don't think about it in terms of reducing costs. And so, how does that work? Well, one of the ways I could say is that, well, if you're capturing special circumstances from the hardware or from other APIs, they're going to affect how the software works, right? You have to understand all those different, again, special circumstances, those, what can happen if the hardware does this? What happens if the hardware does that? What happens if the system goes offline? What happens if these encoders in the motor are miscalibrated, right? What happens if the Wi-Fi goes down, if it goes offline? All of those things need to be handled and should be thought about ahead of time. And again, if you think about them ahead of time, you avoid surprises. And you may not necessarily decide, depending if it's a new product, you may decide not to handle all of them immediately. You may, purposefully postpone some of these because they're corner cases or, you don't anticipate it's going to be a big issue. But at least if you know about it, that will make a big difference, right? And you can plan for handling it in the future, right? And know what you're getting into. I often say that, surprises are for birthday parties and not really exciting in business, right? So if you can get to the place where you're avoiding surprises as much as possible and UX design helps to do that, then you're going to be much better off. And let's see, I think the question was how to reduce costs. The other item I'll mention is that if you can ensure UX has a seat at the table in the beginning, they can think about how the software needs to be put together. And I mean that in terms of like front-end libraries, component libraries, things like that. You can avoid a lot of development overhead, by using off-the-shelf components from different libraries instead of creating everything custom, right? And that can save a lot on front end. So it's another way you can reduce costs is just by getting, agreement on component libraries that should suffice for the application that you're building, with the features now and the features in the future. So that I think that's probably the best answer I can give.
Yeah, that's a good answer. Another question, in your experience, what slows down progress in software development?
Oh, that's a good one. I've seen a lot of this, and this is actually what, if there's, I would say, a reason that we exist at Planorama, it's getting people what they need. And I would say then that what slows down progress is teams not having what they need. And that could be in terms of solid requirements, right? And a process to make sure that they're all communicated effectively across the whole product team, the larger product team. So, for example, if developers don't have the requirements, meaning like they don't have the business logic or they don't have the visual requirements like the UX designs in high fidelity, then they're going to have a hard time knowing what to build. And developers typically are most efficient when they are building, developing software. When we deliver, what we deliver for Planorama for our clients is we deliver the visual requirements, the UX designs. We deliver the business logic requirements. They're typically called user stories, and it's basically a user-centered documentation, internal documentation for how a particular feature is going to be built. And it's what modern software development teams typically use in order to build the features in whatever language they're using, whatever platform they're using. We also write test cases, and we do that to enable QA. And development often gets a lot of the attention, but QA, they need to know what to test against. And so because we happen to be the ones often writing the business logic requirements, we also turn around and write the test cases to test against every one of those requirements. And so you can see that getting each team what they need, or each sub-team, right? Getting the developers what they need, and getting the QA team what they need in terms of initial test cases that they can go off and start building their environment against. That can make a really big difference. And again, getting people what they need so they can be successful in their role, their part in the team, is what we do, and that's how we speed up progress in software development, so we can accelerate that time to market and avoid people sitting on their hands waiting for whatever they need, right? Which is how we try to reduce costs. So that's what I would say.
Okay. One final question, Matt. How do we integrate UX design into our flow?
Sure, that's a good one. Realistically, and I'll tell you how we work with our clients, and at some point somebody's going to think, well, the rubber has to meet the road here, right? And if we get involved, what does that even look like? So for us, we typically are going to have conversations with the development team, and we're going to have conversations with the product manager or the people or person responsible for the product, because in effect, we sit between them, and we're not forcing communication to stop between everybody. Actually, we're trying to insert ourselves in to understand what the product requirements are and what the development team needs in order to execute. And we have enough experience to know what that looks like. So, we can start off and saying, well, here's what we typically deliver. How is this going to work for you, right? And we do that with development and QA. And so what we often are doing is offloading much of the work from developers or from product managers onto ourselves, so they can be freed up to do the rest of their job. All right. So developers, again, if developers are being put in charge of how the UI is supposed to look, that means they're not developing, right? And that means they're more involved in requirements gathering than doing the coding, doing the development. If we have product managers doing the design, that means they're not spending time going out and talking to customers, understanding the competitors in the market, and so on. And so we end up freeing them up, and we usually, people usually appreciate that, because they get to do what they were originally probably hired to do, which was either to understand requirements or to develop code. And again, by us getting involved in that process, and it takes a little bit of time, we figure out what people need, and then we help create the process and the methodology for this. And we've been doing this for a while. It's not our first rodeo, so we can bring in what we know, and we work it out, and we start executing and working towards feature goals and product goals and business goals. And you'd be surprised how smooth the whole process can be once we all focus on delivering what we're supposed to, and everybody knows what they're going to be getting and can consume it and do their job. We really try to smooth out the rug. So that would be how I'd answer that question.
Okay. Well, that concludes our webinar. Thank you all for participating in the SemiWiki webinar series, and have a great day.
Thank you.